understood as I could get from your assignments. So let us look into that. So remember, the Cartesian product was defined like this. It is the set of all ordered pairs, x coming from A and y coming from B. And with this you had two maps, one I called PA and the other I called PB. They are called the product projections. Okay, and what does this? So this goes to A and this goes to B, and what does it do? Well, so if you take an ordered pair, P1 gives you back the first coordinate and P2 gives you back the second coordinate. Right? So we have the first part of the diagram. So the diagram looks like you have a set and you have two functions, one going to B and one going to A. Both of them have the same domain, but one of their codomain is A and the other codomain is B. Now you see what the property said is that there exists a unique function f such that Fa is PA composed F and FB is PB composed F. So it says that there exists a unique way now regarding the proof, I think Ayub told us in one of the previous classes, your explicit formula for this function f is FAT and FBT. Okay? Up to this point, there is possibly everybody, but there is something which possibly you couldn't get the full impact of this. So you see, the first fact that I want to say is regarding this unique f. It doesn't say that there is only one function. There can exist several functions. So let's start with an example. So let's take this. Suppose A is, say, 1, 2, and B is, say, 3, 4, 5. Then A cross B we know has 6 elements. Okay, and you have, as usual, the top line is not very difficult, right? You should still stop me if you find that I am going fast. Now let's take a third set T. Let's take T to be, say 1 instead of 1, 2, 3, 4. Let's take A, B, C, D. So it's a 4-element set, and I'm giving you. So observe how many functions are there from. How many functions are there from T to A cross B? Any idea? How many functions?
I'll take a guess, Doctor.
Yes?
I've got 24.
24. Why?
Because the domain consists of 4 points.
Okay.
And the range of the codomain consists of 6.
Okay.
Let us multiply the two numbers.
And why did you multiply?
When I look at it, I can either take it to the power, or I can multiply it horizontally.
That's my question. Why did you not? Let's try and see. So you want to have a function, right? So you want to have, the function is a relation. So you want to have I'm not writing the second one. That's the blank place. Right? You want to have, you cannot have two, the function will not have two elements whose first coordinate is A. Right? Because that's one of the criterion of a function. It takes each point to a unique point over here, right? Clear?
Yes, Doctor.
So whatever be that set, it will look like this. Any G looks like this. Now how many choices are here? So there are 4 blank places to be filled up. How many choices in this place?
I've lost the screen.
Huh?
I've lost the screen.
Oh, sorry.
Yes, it's back. Thank you. Thank you, Doc.
Okay, 1 minute. This is back, right? Yeah. Now,
Yes, it's
Yes,
back.
Doc, it's back.
okay. So, you agreed that any G would look like this. Only this blank places are to be filled up. Right?
Yes.
Okay. Now, how many choices do you have over here in this for A? How many choices?
6.
6. Good. So over here there are 6 possibilities. Over here?
6.
Yes. No, Rosal, not 5, because
Sorry. Yes.
A and B both can have the same value.
True. Yes.
So here also 6. Here?
6.
Here?
6.
So there are 6 to the power 4. Right? Each option, if you fix any of those elements of A cross B over here, each of them gives rise to further 6 conditions, right? Over here. You fix that also. So therefore 6 times 6 times 6 times 6. So that is 6 to the power 4. So you can actually therefore say that from a n element set to a m element set, there are
M to the power n.
yes, m to the power n functions. And that was one of the so from an n element set say P to an m element set say Q. So the number of functions, there are m to the power n. So there are m to the power n many functions, and that's one of the reasons of choosing this symbol for the set of all functions. So you see the power, the as if we were saying. So the symbol tries to say that it is so m to the power n. So this number of elements over here, if I denote by this absolute sign the number of elements of P, so this is the number of elements of this. So that is one of the reasons of choosing this symbol, but there are other reasons why I also choose this symbol, but that's another issue. Okay. Now, so therefore, from T to A cross B, there are, as you have said, 6 to the power 4 functions. But what I am saying, of these 6 to the power 4 functions, there is exactly one function whenever you have given me. So sorry, I was very fast here. So now suppose you have chosen a function here. And a function here. Now how many functions can you choose for FA? How many functions can you choose from T to A? Here?
4 to the power 2.
This is A, 4, it is the other way round. The other way round.
2 to the power 4.
Yes. Right? you can have 2 to the power 4 many choices for FA, and you can have how many over here?
3 to the power 4.
3 to the power 4.
3 to the power 4.
Now whenever, so therefore remember, the number of choices that you can make for FA and FB. So the number of pairs so how many such pairs FA and FB can you make? There are 2 to the power 4 choices for FA and 3 to the power 4 choices for FB. So how many choices?
The product of that.
Yes. And that is obviously 6 to the power 4. Okay? So observe, the number of functions from T to A cross B and the number of functions, number of choices, the total number of choices for this pair, they are exactly the same. But what I am saying is, you give me one such choice. So you take one choice of FA and one choice of FB. Then you can choose a unique function f over here. Okay? Such that, so
say that again, please.
yes? Yes?
How do you know that you can only choose one?
That's the property. That's and what is I'm saying, what is, you can choose only one function. I have not finished. Such that PA composed such that FA is equal to PA composed F and FB is equal to PB composed F. So you can choose one and only one function such that both these equations are true. So which we say that this diagram commutes. Okay? So this diagram commutes means it's producing two equations. So there is only one way that both these two equations can be made to satisfy. And it turns out, as you already observed, that Ft has the formula Fat and Fpt. That's the formula for this function. So, observe, for each choice of this pair Fa, Fb, you have exactly one. Okay? You have exactly one. So, that is the first bit that I want to emphasize. It is not saying that there exists one function between T to A cross B, but there exists one function satisfying both these two equations. That is the first part. Okay? Alright? Now, let's see some trivial cases where I am going to use this observed fact again and again. So, suppose I take over here A cross B itself, and I take over here PA and PB itself. Can you quickly tell me what would be this line?
The unique function.
Yes, the unique function, yes. Which one?
Identity.
Yes. Yes, exactly. You don't need to think, because what's the clue? I need this function, and I need a function which satisfies this diagram. So let me, as a trial, put identity over here. Let me try and put that. Let me see. Well, this one composed PA is obviously PA, and this one composed with PB is obviously PB, and therefore the product says that this has to be the only one. There can exist no one else. Okay? Let's take another example. Somehow, so this is PA. Now somehow I am saying something like this. It's B cross A. Now this one, the projection I am denoting by PB prime. Okay, just to, and this I am saying by PA prime. So these are also projections. So it is something like this. So this is PA prime, it takes it to A, same, but since okay. Now, how would you fill in this one? So you know that there will be, now you are a little bit, give me a formula. I am saying give me a formula. So what do you think should this formula tell you? You know that there will exist one, right? And what is that formula?
Is it not the inverse?
PA.
What is it?
Is it not the inverse?
Again, would it not be?
The inverse function.
So specify what is the ordered pair here?
A to AB.
Yes. Yes. So it just reverses the order. Okay? And this I can see, F composed PA, PA composed F is obviously PA prime, and PB composed F is PA prime. PB prime. Now, since let's go a little further. You have
Doc,
Yes.
can I ask a question on,
Yes.
on the end?
On the
way, the significance of that, because you say PA composed with F equals to PA prime.
yes.
When you look at the arrows, if you follow the arrows, your PA, they'll go opposite. Like PA faces upward,
Yes.
PA prime, or PA prime, then it goes counterclockwise, meaning it goes against the arrows. Is there significance in that, or
No. No, the commutativity. No, there is no. What do I say? Speciality in how these arrows are drawn. I could have drawn it like this also. So it's not about
Yes,
how
I was
this.
saying
How
where
this.
the arrow is pointing,
Yes.
not where the line is straight or not, but where the arrow is pointing.
Yes. Yes.
There's no
Exactly.
significance in that.
Yes, the only significance is from which node to where it is going. So, roughly speaking, the commutative, we say that this is the rough idea behind commutativity. When we say, so if there is a path here and a path here, and then there is a third path here. We say that this one commutes, it means that if I label this A and this as B and this is C, it means that, so from here to here and then followed by here to here, that is B composed A. On the other hand, from here to here I have, so let me give 3 symbols. From square to star I come by C, and from square to star I first go to this circle and then from circle to star. So that's this. Commutativity means that when I say that these two this diagram commutes, it means that this. It just simply means this. It doesn't matter how I draw those arrows. Okay? So the fact that it is pointing this way and this one is going anti-clockwise or whatever doesn't matter, because from this node to this node there are 2 paths. One is this direct one and the other one via A cross B, and we say that commutes means this followed by this is nothing else but equal to this, which is this equation. Is it clear? Yeah?
Yes.
Okay.
Yes.
So, now B cross A, these are also these projection maps. And see now, you have a similar diagram over here. From another set, you are having this. So, you therefore have also a unique way to come down. Right? There is also a unique way to come down. And what will G do? What will G do?
Yeah. BA.
BA. Good. Now see, if you give me this formulas, so therefore I can see G composed F. So I start with the BA, go to AB, and then I come back to BA. So this is identity of B cross A. And F composed G is also the identity of A cross B. Okay? Well, this is fine, but I am trying to enforce this diagram argument. I am trying to say here something. Now listen carefully. So the first step is, you have told me there exists a unique function f such that P prime A is equal to PA composed F and P prime B is PB composed F. Secondly, you told me there exists a unique function G such that P A prime let me write it as I did before. P A is equal to P A prime composed G and PB is equal to PB prime composed G. Right? Now let me try and see. PA. This is equal to, you have told me, it is PA prime composed G. But PA prime, you have told me it is PA composed F composed G, which is PA composed F composed G. This is associative. Similarly, PB is PB prime composed G. It is PB prime is PB composed G, composed F. Did I do it right? Yeah. Composed F, composed G. So this is PB composed F composed G. Now observe, that's why I did this. The unique function such that PA is equal to PA, if I call this say H, and PB is equal to PB composed H, you have told me this means that H is the identity. Right? That's the unique one. In fact, it is both ways. Right? So H, identity of A cross B, is the only function which satisfies the. Now you see, there is a. I'm suppressing I'm suppressing some part of the strength only for the purpose of my argument. In fact, you know, if you take the identity function and you take any other function F composed identity is still F. That's true. But I am saying in particular, therefore, the only function H which satisfies these two equations is this. That's the strength. Right? That's what I am going to use. You told me this. But you have told me F cross G is also doing the same thing. PA is equal to PA composed F cross G. PB is equal to PB composed F cross G, and therefore F composed G must be equal to identity of A cross B. And similarly,
Hi, Doc. I've lost the screen.
We've lost.
Okay, yes, Stanley. I saw your hand just now. Yes.
It's back now.
Okay. So similarly, okay. So you see, there is a difference between the way I argued in this blue color and the way I argued in the others. Here, this one I needed that explicit description of the function f, which is there, as well as the function g, and I computed it and I said it is this. I deduced this. Well, that's fine. But you see, you can also do this by using the property. So this f has an intrinsic property, and that's exactly the diagram argument which I am trying to force, which we will see again and again. Okay, that's another diagram argument. This, you will see this diagram argument coming, and once you get used to it, and once, see, diagrams sometimes speak out, in a sense, they bring out the pattern, the inherent pattern, very quickly to your eye. That's why we draw diagrams. There is no reason to embellish or decorate the thing. The whole idea is, diagrams, as we have just seen, these diagrams are nothing else but certain equations. It just tells us some equations. So it is just a diagrammatic way to write an equation. But sometimes diagrams, the power of diagrams is, from the pattern you start to think, you start to recognize pretty quickly just by recognizing the pattern. So what is the pattern over here? The pattern is, if you see over here, you try to think as if, so what is this trying to say? It says it looks like a set along with two hanging things, two hanging arrows going to that same. Now such, if you fix those two endpoints, if you fix these two endpoints A and B, of all these hanging arrows to A and B from a fixed set, this one on the top has a speciality. It seems as if every other thing moves, this dotted line, as if it suggests a movement. It moves in a unique way, it deforms in a unique way to this one. So as if it is trying to say that every other hanging arrow from a set to two fixed points deform in a unique way to the product. So that's the picture that it is suggesting. Okay? So whenever you see this, and this one has to be the product. So whenever you have a product and these two, you are going to utilize this. Okay? So now if you see this other one, so we have,
sorry Doc, we've lost your sharing.
Oops. Okay.
It's fine now.
Okay. So you have these two. So now you see, if you look into this, there is an intermediate step. So if you compose this part is obviously PA composed F. and this part is obviously this part is obviously F composed PA, and this part is G composed PB. So now you see, you have this hanging from A cross B, you have fixed this C and D. This is the product. So therefore, there will exist only one choice. There is only one choice for H. So there exists only one function such that PC composed H is equal to F composed PA, and PD composed H is G composed PB. Okay, and then it provides this one. It is enough to have this, but property wise, but explicitly now we can explicitly in terms of elements. So let's see. Suppose H say of something U, say AB. This is equal to CD. So C is PC of CD, but PC, this is PC of H of AB. But this you told me from this equation, this is F composed PA of AB. So this is FA. And similarly D, this is PD CD. So this is PD of H of AB. This is PD composed H, this is G composed PB of AB. So this is G. So you know this, so therefore, so explicitly H of AB is what? F of A. But you see, this H is completely determined by these two equations. Is this clear now?
Yes, Doc.
Okay. Now there is another thing. We will see. Actually, I am jumping. So something about this connection. You saw you saw the number of choices of FA and FP. That's 6 to the power 4. And this is equal to the number of functions from T, number of functions right? That was also you saw. Okay? And so what is this number of choices of FA and FB? Well, so that means you are taking this set. Such that you have right? Right? This is the first element these are the elements from here, this set, right? And the other one,
Yes.
the second one is it is this, right? The set of all functions from T to A cross B. Now, in general, so let's see this. So I'm going to give a function. So from this you can see, well, let me give a name first. Let me say this script SAB, just to avoid a big name. So it's the set of all pairs, so all these choices, so these are coming from here. So I'm going to define a function. So what is the function doing? I take a function from A cross B, from T to A cross B, and I'm taking it to PA composed F and PB composed G. See, this is, so I draw this. I copy this. I'll need this again. Sorry, draw it here. What up? Yeah. So that's what I'm doing. So I take a function f and I take it to this. So this is the function. Okay. Now observe, what is this saying? It is saying that given FA and FB from SAB, there exists one and only one F. Such that H of F because H, what is H of F? You know, it is H of F is PA composed F and PB composed G. So that's what this equation is giving us. Okay. So in other words, I'm a little bit I'm jumping. So this is exactly what is known as saying H is a bijection. And just to, so again jumping much more, just to, whenever there exists a bijection, having a bijection is one way of saying that the two sets have the same number of elements. And that is exactly why you obtained this equation. The number of choices for this is same as the number of such things. And this is exactly the scenario that you have. Okay? So remember, this diagram is very, very, it conveys a lot of information, and only the tip was said, and it is, I accept, it is a little different how we are approaching this. We are more how do I say, used to this computational style. Where is it? This one. So we would compute explicitly and then do the computation, this computational style. While that is not incorrect, and in simple situations such computations often help, but this is the problem with any computation as such, and that is you get bogged down with the computation, and the properties involved get veiled, get shadowed. You don't concentrate on the properties. So what I am doing is, I am saying, in addition to the computation, you must not forget these simple structures, these simple properties which are also there. And why am I doing so? While at this simple level this computation is doable and easy, when things get complicated, the computations also get complicated, but the structures get themselves revealed, and much of the computation can be immediately hidden. You see, in this code, in this blue part, as I have said, I never used how f looks like, but just the computation told me it's f and g are inverses of one another. They are just so we will see again, come back to this and see it. So f and g are bijections actually. So you see, I never actually computed explicitly how does f look like or how does g look like, but I still concluded what you had also concluded upon a computation. And this looking into the properties is, in a sense, much more effective in reducing not only the computation but in bringing out a structure, in bringing out. So we will see many of these diagrams getting repeated, and then we will have a general way to study such patterns and so on and so forth. So that's I felt that while going through your assignments, that the questions regarding this was not properly tackled. So I thought that one should look into this again a little more closely, and hence I did this today. Any questions, any further doubts on this or any other thing? Yes? Any doubts?
Looks like it's clear, Doc.
Okay. Okay, Stanley, it seems that you wanted to say something long time ago. Because if you put on something in this chat, I am on another screen, so I cannot see what you're saying.
No, I think you answered. It was the question of the arrows, whether they had meaning or not, and then you did deal with it. So I'm comfortable.
Okay. So we didn't do anything new today, but anyway, this is also important. Any further questions, or should we stop, or should we? Oh, it's already 1 hour. Is it? Yes. Okay. So we are supposed to stop now, but yeah, whatever you say. If you want to stop, we can stop, or we can continue with the next one, or whatever problems you have, I can try answering them.
Dr. Still, just one question.
Yes.
Did Doctor manage to do the recording of this session today?
Yes. I was recording it.
Okay.
Yeah, sorry, I didn't tell it before, but yes, I was recording it. Yeah.
Thank you.
Yeah. Okay. So, any further questions?
No further questions from my side.
Anyone else?
I'm okay, Doctor.
Yeah?
No, I'm okay, thank you.
Okay.
I'm fine, thank you, Doc.
Yeah, Charles?
I'm alright, Doc. Maybe we may stop for today.
Okay.
And then if there is anything, we'll let you know, yes.
Mavutu?
Yes. I'm fine, Doctor. I'm okay.
Okay, so let us stop today, and then next week we go ahead if you don't have any further issues. Okay.
Thank you, Dr. Josh.
Okay. Keep well.
Thank you, Doc.
Thank you. Keep well.
Thank you.
Thank you. Thank you, Doc.
Thank you, Doc.